There's a common data structure in programming called a stack, which typically supports three operations. You can push an element to the end of the stack, you can pop an element from the end of the stack, or you can look at the last element in the stack. Meaning in this case, we just read the last element without removing it like we would in pop. These operations should run efficiently, so pushing should be a constant time operation, popping should be a constant time operation, and peeking at the last element should be a constant time operation. So do we need to design a data structure from scratch to be able to implement this? No, the dynamic arrays that we talked about earlier actually satisfy all of these requirements. So a stack can be implemented using a dynamic array. So typically when we're programming, we actually just use the default dynamic array that's given to us in the language that we're using. So remember, our stack is nothing but an array, and we're allowed to push elements. So we can push a 1 onto the stack, we can push a 2 onto the stack, and sometimes people like to think of stacks as being vertical. So when we say we're pushing onto the top of the stack, we're throwing a value in here and it gets thrown to wherever the top of the stack is. Since right now it's empty, it'll go to the bottom. Now in reality, we would have some kind of pointer, or we would maintain the number of elements that are added so far. So we would know exactly where to push the next element. Let's push a 2. It's going to go where the next empty spot is, which is now going to be shifted here. Same thing with the vertical representation. We push to the top of the stack, which is considered the end of the stack if you're talking about a regular array. And we can keep doing this. Let's push a 3. We can also now push a 4. Even though technically we don't have space, we know our stack is implemented with a dynamic array, so we don't even have to worry about running out of space. We know it's going to end up allocating some more space for us anyway, so we don't even worry about that. Stacks are just one common use case of dynamic arrays, but we can also support popping elements. So when we pop, we can only remove elements from the end of the array, but we know that's efficient. So we're, in this case, popping from the top of the stack or the end of the array. Internally, we wouldn't necessarily delete this portion of memory. We would just say that this is now the new end of our array, or this is the new top of our stack, and we can keep popping elements. Notice something about the way the elements are being inserted and removed. Remember, we first pushed a 1, and then we pushed a 2, and then we pushed a 3, and then we popped a 3, and then we popped a 2, and now we can pop one more element from our stack, which is the 1. So notice how the order that the elements were inserted in is the reverse of the order that the elements are removed in. In other words, the last element that was added to the stack is going to be the first element that's removed from the stack. The second to last element that was inserted is going to be the second to last that was removed if we pop all of the elements. So stacks are considered a LIFO data structure. That means that the last in is going to be the first out. There are many use cases for a data structure like this. The most obvious one is the one that we kind of implicitly just showed, meaning we had some sequence of values. In this case, it was numbers, but it could have been a string of characters like ABC, but the order that we added them in was the reverse of the order that we removed them in. So we could use a stack to reverse a sequence if we wanted to, even though there are other ways of doing the same thing. There are definitely a lot of other use cases for stacks that can get a lot more complex. And as you solve problems related to stacks, you'll definitely notice this. We will continue to talk about stacks throughout the course, but if you want to practice using this data structure, you can find some stack practice problems in the practice section.